Hi guys, and welcome to part 2. I'm going to try to streamline this, just go over really the key differences in these two transmissions, the weak points of the AOD and the strong components of the 4R70W, and how to make them work together. If you're looking for step-by-step tutorial of all the details, there's much better videos out there, so I'm going to spare you all that. Bad Shoe Productions is an excellent series that even a high school kid could follow along and rebuild a transmission with those videos. So check that out if that's what you're after. Now, these are the reverse drum assemblies. This is the AOD, this is the 4R70W, and these are the overdrive bands that clamp down on these. And as you can see, the AOD is only 1.5 inches and is a known weak point of this transmission. The surface is also wider on the reverse drum to accompany it. Also, with this component, you have one-way clutch, is a roller clutch. The later models were pretty decent, but the 4R70W is going to have what they call a mechanical diode. It's like a ratchet and pretty much bulletproof. Inside is the reverse clutch pack, and as you'll see, the AOD here has 4 frictions. The 4R70W only has 3. Now, this is because the Ford engineers figured out that 3 was enough, and 4 just created a little bit more parasitic drag. You know, they're always looking to get squeeze any kind of mileage they can out of these. These are the intermediate clutches, so second gear, AOD, 3 frictions and a pretty thick pressure plate there. 4R70W, 4 and a little bit thinner pressure plates, so this whole pack will go in our AOD. These are the Planetary gear sets. As you can see, 4R70W, much bigger. More importantly, the gears are harder, so able to take more horsepower and torque. And most importantly, you have a wider ratio. So first and second gear in this set is going to be lower than this set. This is a close ratio. It has its application. Sports cars probably better off with this. I'm not driving a sports car. I'm interested in a wide range gear set and harder gears, so I'm going with this. Now, this is going to affect your shift points. With this gear set, first and second are going to shift later than they would with this set. How much later? I don't know. But that's all controlled with the throttle valve pressure and the governor. So this goes on your output shaft. Pretty simple device. It's just got a plunger in there with a spring. The faster it spins, the quicker it shifts. So it's going to be spinning a little slower in first and second with this lower set, and it's probably going to shift late. There are 3 different governors available with heavier plungers and or lighter springs. I'm going to put this one back in there and just see what it does, because I still don't know. I still don't have a baseline, and everybody's situation is different. It depends on your rear end ratio. Also, I've got a 3.0 in the van now, which is pretty low, and I've got a 275 third member ready to plug in if I want to, and we'll see. This is pretty easy to get to. If you just pull the drive shaft and the tail housing, you can pull the governor out and have your way with it. Add some weight or change the spring. Not that difficult. These are the forward clutches. This is a later AOD that has the same stamped steel basket as the 4R70W. Each one carries 5 frictions. If you have one of the older AODs, you can put this basket in. You just have to press the shafts out and put the newer style basket on your AOD shaft. And so this whole 4R70W heavy duty gear train, minus the input and output shafts, will all go into your AOD case. And so when you're looking for a 4R70 donor, I believe 98 is kind of the magic number. Post 98 had all the major upgrades. There were little ones also along the way after that, but and then the transmission's put behind the 5.4. So pickup trucks, vans, and SUVs with the 5.4 are going to have the heaviest duty components. This one I have is out of a 2002, I think it was an Expedition, which was wrecked, and I couldn't read the mileage, but I'm guessing this thing had maybe 50,000 miles on it. I wouldn't be ashamed to put it back together the way it is. It's pristine. But yeah, looking for a wrecked one is usually the best bet, because you know it was running before it got to the junkyard. All right, so this is a great example of why you should closely inspect everything, especially on any component that's been taken apart before. I don't care by who. So this is the governor valve assembly, the housing, little filter. This is the plunger assembly, and this spring here ain't supposed to be there. It was probably put in there to hold this back some and delay the shifting in here, but no matter how this went in there, it didn't allow this plunger to make the full travel. So I don't know if it would have even worked at all. And this is exactly what I don't want to do with this transmission. I want, with the low gear range, I want it to shift sooner, not later. But in my case, the governor is probably not the place to do it, because that's going to alter the shift timing for all 4 gears. I only need it for first and second. So the valve body is where I need to be making a modification. Now this is a modification we can do to this pump stator. So this port here is the output for the cooling system. Normally it has a spring and a check ball inside. I've already removed these, and I apologize for not filming that. It just went so easy, it just happened. But anyway, these 2 pieces in here are a major bottleneck restriction for the cooling system. Cooling these transmissions is number 1. If we would have had adequate cooling systems on automatic transmissions, there probably never would have been these huge nationwide chains like Amco and Precision that have been making money on transmission rebuilds for decades and decades. Now I'm going to have a really big aftermarket plate type cooler anyway, but you know, anything to help the flow is going to be a plus. The purpose of this as a one-way check valve is to prevent the possibility that the torque converter will drain while your vehicle sits. This may or may not happen. If it does, it will pump right back up, but it may delay it going into forward gear when you first start it up. If that happens, you can always install an external one-way check valve in the line, either in the feed or the return line. Return line's best. That keeps it cool, and either one is fine. Now, the way I removed this was to hook the little spring in here and just pulled that out. The plug that goes in the side, you need to pop this plug out. So first you stick your punch in, and you can pry against this ball to get it pushed out a little bit, then tip it back until your check ball falls down in here, and then you've got something else to push against with your punch, and then this will pop out. It was pretty easy. And then now that I've chamfered these holes and blown everything out, I'm gonna pop this back in. On all of these lip seals, the lip is always going to face in the direction of the hydraulic pressure. And getting these lip seal pistons back in their bores can be pretty tricky. I've got these installing sleeves, and I've seen even professionals struggle with these. This will be my first time, so we'll see how it goes, but I think the trick is to get the installer over the seal first with some lube in there, so it's kind of already compressing it, and then put the whole assembly down in there. And there's no need for a sleeve on the inside, because the seal here is facing down, so it should just pop right on there. Looking good. They do, of course, make special presses to compress these springs. This works. It's a little crude. Now, when I was watching Nick of Nick's Transmissions doing a build on one of these, he was putting the frictions in the packs without soaking them first. And then at the end of the video, he made a very good point that maybe these transmissions are going to sit around for months or even years before they're installed. And so when you first start them up, you want to let them run for a good half hour before you try to put them in gear. That way everything gets soaked like it needs to be, and it's fresh and ready to go. I'm going to do both. This nice little tub, $3.50 from Walmart, keeps my fluid clean. And then these all go in bags while I'm building the rest. Forward clutch, again, you want the installers on the piston, helping to pre-compress the seals first. You don't want to put the piston in and then try to shove these down around it. This thing fits way too tight on here. I'm gonna try it without it. And these are square cut on this, so not as tricky and critical. This center one was a little bit too tight, so I removed it. The cone in here is really nicely tapered, so it's no big deal for it to slide over that. The factory snap ring that holds the mechanical diode on is a known failure point. So I have these spiral lock snap rings. They just kind of slip in the groove, and then they have a retainer that holds them. There's actually 3 sets in this package. This piece here goes on first. And then the ring spirals in. Just like that. Make sure we're all in. And then we just have to stake this retainer on here. Make sure it doesn't come apart. Easy enough by hand. No need to get crazy with hammers and chisels. So now all my clutch packs are built, and so all the rest of this AOD gear train can be cleared off the bench and get ready to start loading the case. This is my relief slot ground in the output shaft, just in case the input shaft ever wears to the point that it makes contact and blocks this hole. Now, I've seen guys assemble these a few different ways. It makes more sense to me to go ahead and get your output shaft in the base flange and get the snap ring on before installing the sealing rings. And since I'm using the 4R70 gear set, there's enough room to put the direct drum in afterwards. Otherwise, you have to assemble it all together. Got the bearing on. And this is the support ring for the reverse band. It's just an installation aid. There's no slot for it to clip into. I think it's best to leave the open end there where both ends are supported instead of one just hanging off in a trough. Then our reverse band. And the Planetary. And so now I want to go ahead and put my reverse servo in just to make sure the pin is definitely engaged in the band. And of course there's a special tool for this, but this is just a piece of universal angle iron and a couple of valve body bolts and a long threaded bolt. I've got the cover now pressed in, and now I can put my snap ring in. The center support here has to fit in to the one-way clutch, so one of them has to spin counterclockwise to get it to fit in. That's possible to do with the one-way clutch and Planetary already installed. So line this notch up with the pin in the side of the case and just set it in place where it needs to go. And then to seat it in the one-way clutch, just need to drop our basket in there and give it a spin. Just like that. Install this anti-rattle clip in this position right here, just like that. And just make sure that it is level. These two little tabs are level with the center support and just below the snap ring groove. And so on both our sun shell and sun gear, you want to grind some little oil channels just to maximize oil getting from inside here out to the gear set. And install these. So this is the factory Overdrive servo. It's a B. That's the middle one. There's A, B, and C. This is an aftermarket A plus super servo, and it's even bigger than an A. So the bigger the slave cylinder, the more leverage. Same gig here, boys. You just got to find two bolt holes directly across from each other and compress it down till you get your snap ring in. And then we can verify the overdrive band is engaged on the pin. Okay, so I've got the intermediate clutch all loaded in here, 4 frictions and 4 steels, all from the 4R70W. In place of the 3 that were previously in this case. Now to set the clearance of this, there's a proprietary measuring block that runs across this surface, which is a calibrated thickness, and then you're supposed to measure from there down to here for the clutch clearance, and from there down to here for your end clearance. I'm not going to invest in that for this one build. So Jay from Broader Performance says that measuring from this surface down to your first steel is going to give you your clutch clearance. Alright, so I was having some doubts about this surface to the top of the steel being your overall pack clearance, so I thought I would double check on the pump. And so measuring from this surface with the gasket down here, I get about 920 thousandths. So then I popped my retainer plate off the pump so I can get a straight edge right across the top of the piston and measure to the mating surface. And I'm like right at 900, so about 20 thousandths discrepancy there. Your mileage may vary. I would check this, make sure your piston is seated all the way down with the spring plate off, and you know, take a few measurements around the outside. I got consistent 900, so add 20 thousandths then in my case to that measurement. And so I was measuring, counting the 20 thousandths, about 65 thousandths, which would probably be okay, but was on the high end. So I swapped a thicker steel out of the old clutch pack that got me another 10 thousandths. So I'm going to be happy with that. His method also for the end clearance is just to stick the pump in there with the middle of the road, what they call natural color selective in there, and both these transmissions had this, and just feel it. So I'm just going to drop the pump in here without the O-ring just to check. Okay, at first I couldn't feel anything. It turned easily enough, but I couldn't feel any end play. And then I thought, well, you've got a lot of assembly lube in there, so I put pressure on it while twisting it and pulled up on it, and then I finally got some movement. Feels like maybe 20-25 thousandths, and I'm going to try to get a measurement. All right, so after about a dozen measurements from the stator support to the top of the shaft, holding down and pulling up, I got about 22 thousandths, so that was a pretty good guess. And another fabulous tip from Jay of Broader Performance for checking the intermediate clutch is looking through this little window right here. That's the intermediate clutch. Obviously I have clearance, looks like plenty. I'm going to stick that in there and get a good look. Now, pull the pump back out, do one last check, get the O-ring on the pump, seal it up and torque it down, and that's probably going to conclude it for part 2. Valve body being part 3, which is a whole nother chapter.